Chapter 6, Section 3 begins with the VSEPR or VSEPR theory, which stands for valence shell electron pair repulsion theory. And this VSEPR theory is going to predict what our molecule shapes are going to be. And that's all based on the position of the electron clouds. Electrons are all negatively charged, so they want to position themselves as far away from each other as possible, which is then going to determine the shape of a molecule. These are some of the basic shapes. You could have a linear molecule, which means that the atoms are arranged in a straight chain. You could have a bent molecule, something like the water molecule, where you have a central atom and two elements that are attached off of the sides of that in a bent shape. You could have something that is trigonal planar, which means that there is a central atom and three atoms attached to it. And they would all be then 120 degrees apart from each other. That would be as far away as they could get. And so it's in a flat plane. That one is going to be distinguished between trigonal pyramidal by whether or not there's a lone pair of electrons on the central atom. With trigonal planar, you do not have a lone pair of electrons here on this middle atom. With trigonal pyramidal, the central atom has a lone pair of electrons that's going to push down the bonds of the three other elements that are attached to the central atom and force it into a pyramid shape. And finally, the last one that we're going to talk about is tetrahedral. Tetra, if you remember, is the prefix for 4. And so with this one, we're going to have a central atom and 4 elements that are attached to it. The last thing with shape is that the shape can affect different properties that the element has, or that the molecule has. In general, the greater the polarity of the molecule, the harder it's going to be to break, so it'll have higher melting and boiling points. So for instance, we talked about dipoles before, and things that are nonpolar or not dipoles, such as the carbon dioxide molecule here, is going to be easier to break apart than something like water, which is a polar molecule where it has an uneven distribution of charge. So you have the partial negative charges on your oxygen and the partial positive charges on your hydrogen. So this one would have higher melting and boiling points than the carbon dioxide would.